Okay, so we are continuing from part one where we left off. So we're going to draw this top strand of this DNA molecule that's been opened up. And bottom strand was green, you said? So the bottom strand was something like this. And what had happened is we had the helicase protein enzyme, which had opened up or unzipped. Okay. We can draw him. I think he was red. So the helicase is operating here at this point. So we'll shade him in with our crayon, just so he looks like a big chunky protein working on that part of the molecule. And he's moving, of course, in the direction. Oh yeah, we should put the directional markers in too. So let's do that first. And I believe the top strand in our previous example was the 3 here and the 5 here. Is that right? We're good, because we can't mess that up or it'll really screw things up. And then we had the 5 end here and the 3 end down here for the green. So what we had done is we had seen that after the helicase opens this up, primase comes in and inserts these little RNA primers. So I'm going to use a different color this time because last time I was using that lime green and it wasn't showing up very well. So I'm going to change to this really bright yellow for the primers, okay? So a primer was put here at the start. And it's because the movement of these enzymes along the molecule is one direction only. So I'll put in this piece of primer here. And of course, we have these little bases that are, excuse me, are being ready to attach. Now, the primer inserts this piece, which is now serves as a starting point for the DNA polymerase 3, which would attach here at this point and begin to assemble the piece of DNA that goes sort of with this section. So I'll put it here. And I don't forget what color I use for DNA polymerase. Do you remember? Let's use something sort of different. I think it was an orange, actually. Let's use this orangey color. So here's the DNA polymerase right here. And of course, it's moving this way, right? And the helicase is moving this way. So it's basically following the helicase. And so we'll color that in too with our crayon. And we'll get that nice sort of, what was it, orangey color. There he is. And of course, what he's doing is building this other strand, this green strand, assembling it onto the purple strand. So we'll put some black little markers for our bases in there, the base pairs here. Okay. On the bottom, however, because these enzymes are always moving in the same direction, they have to basically move backwards. So what has to happen on the bottom is the primase has to insert a starting piece of RNA here, but it also has to have other pieces or markers that tell the polymerase where to stop. So all along the bottom, every so often, you will get a marker. In other words, right here, this marker is put here. Why is it put there? Well, that's right behind the helicase. You can't put it any further ahead. So it inserts the marker. But a little later, if you imagine this animated, that marker next to the helicase will be the one way down here, right? And so it will leave behind it, and then they'll put another one in further on, and another one, sort of always inserting them right behind the helicase, which produces this staggered effect. And so we get these little RNA primer pieces all sort of staggered along. And this is where we sort of left off. And I'll put these guys underneath here. And then, of course, on the bottom, we also have a DNA polymerase. So let's put him in there. Sorry? Well, yeah, but so what would happen is a DNA polymerase would be working here, but it would also be working on the other section. So on this one, he's going to go this way. on this one, he's been working longer, so I'm going to put him near the end. He's pretty much done. He's gone as far as he can go, right? He's kind of hit the wall. He's hit the next primer. And I'll shade those in, kind of showing what's happening as time goes on, right? So remember, you have to think about this as an animated process. And so his job is to reassemble, and he'll be assembling this nice purple. So he's going to start to assemble the purple, but I'm only going to draw a little bit because obviously he hasn't gone that far. But this guy has gone almost all the way to the end. So they are building these purple sections, which are essentially the top pieces of our original DNA strand. So those are the RNA polymerase 3s. Remember that, RNA polymerase 3. And that's where we sort of left off. And we said that on the top we get a nice smooth piece of DNA that's being made that'll follow the helicase. The only thing that we have to worry about is just one little piece of primer RNA at the start. But on the bottom, because we have to keep going backwards, every time the helicase moves, an RNA is inserted, and then it moves a little more, an RNA is inserted, you get these fragments. And we called them Okazaki fragments. So these pieces right here of DNA that are like the purple piece there, it's called an Okazaki fragment, named after the scientist who sort of discovered or isolated that. And that's about as far as we got. All right, let's carry on. So now I'm going to redraw sort of the next picture, and I'll just move down a bit more. Yeah, purple on top. So here's where we're at. We have a purple strand at the top, and the helicase is on its way. We have a green strand on the bottom, like that. And we have a little piece of RNA that's been put here. And on the other side, we have these little pieces of RNA that have been attached sort of all along. Maybe there's another one starting right here. And we have on the top a nice piece of DNA that's being made all the way to here now. So the DNA polymerase 3 is just working along, and the top is looking good. Oops, black. All right, we'll put in some lines for our bases. So the top part is looking good. The bottom part, however, only has these little guys. And because it's working backwards, it's got pieces of DNA that have been inserted this way. This one will be finished. The one over here might still be going, right? So it's kind of being built. You can imagine that there's a little DNA polymerase working along there, right? And so we have all this, whoops, colors, thicknesses, and that one's not quite done, so it's being built. And so this is what it's looking like. It's getting there. So next, what we have to do is we have to change the little bits of RNA into the corresponding DNA. And so what happens here is another enzyme called DNA polymerase 1. Right? They're called 1 and 2 and 3 because of the order in which they were discovered. So that's not anything to do with their function. It's just the way they're called. So what it does is it removes the RNA nucleotides. So now we need another enzyme. Let's use a new color, maybe this really light blue or something. And let's draw an enzyme that would be sort of operating here, moving along this little RNA fragment. This one will be almost done, so we'll put it, because it started sooner, right? And we'll color those in with our crayon. It's not super visible, but you get the idea. While we're at it, we'll need one at the top too. So let's do that one. There's a piece up there that has to be fixed. So this one will be almost done as well, right? Okay, on. And we'll color them in. So this is DNA polymerase 1. I'll write that next to it in a different, just in black because it's DNA. I'm going to put P for polymerase and a 1, okay? DNA polymerase 1. We've already seen polymerase, so you know what that means. And you can see it's working here, and in every case, it's moving along that little fragment in this direction. So what the result would be is that it would be changing. So I'm going to rewrite this as green. You see, these would all be turning into DNA pieces because this one's just getting started. Oh, those should be purple. Crap, on the bottom, right? Green on the top. These are turning into purple pieces. So the DNA polymerase 1's job is to change the RNA primer pieces into regular DNA. Yeah. Yep. Oh, yeah, no, sorry. Good point. Went too fast. The one on the top is obviously going in the opposite direction, right? This one would be going, so, yeah, let me have to redraw that. Hang on. Good point. Rats. That's what happens when you don't stay focused. So this one is actually, by the time it's done, it's moving the other way. So let's redraw that guy. He'll be very close to the end of that fragment here. The ones on the bottom are okay, but he's actually going this way. And so the effect would be, we would still have yellow primer, well, right sort of here, and he would be inserting the green all along here. So it would look more like that, right? That's a good correction. And it would be nearly done. So we could maybe put the green almost over there, finishing up that piece. Okay? Now we're doing better. They're changing the RNA pieces. They're disassembling one nucleotide at a time and reassembling a DNA nucleotide in its place. And over here, we would still have our little brown dude still working. So here he is. This is the DNA polymerase 3, who's still chugging along here, finishing up that Okazaki segment, right? So that's kind of happening. Yes? Yeah, so it's not a sequential thing. It's continuously happening all sort of at the same time. However, certain things have to happen first. So as this opens, as the helicase moves down, immediately the primases will come in and start putting in the yellow pieces of RNA. As the helicase moves on, those will move along with it and keep doing that, leaving behind all these open section, which then will have the DNA polymerase 3s will come in and start attaching DNA according to where those primers are placed. Once they're done, the helicase has moved even further, right? All the other stuff is moving down the line, so they're going to go down the line and keep working down the line. It's like an assembly line, essentially. And then what happens is this stage where the DNA polymerase 1 comes in and changes it. So then there's basically only two things left, or one thing left. What we now have then is this. Once this is finished, the way down the line, we have this. Okay? And if I continue this picture way down here, okay, so now we have all of this, all the RNA is gone, and there's now another protein. And what this protein does, is it comes along and it joins. Whoops, black. So let's put all these pieces in here. I should have left a little space, and I didn't. So because the bottom piece here I'm going to put a little space right there. That used to be the RNA fragment. It's been replaced by DNA now, remember? And this is all just normal. Along the bottom, we'll have several little spots that were replaced by DNA segments, like this. So the little RNA primers are replaced, but they're not totally attached. Oh, black. Here we go. They're not totally attached. So what has to happen now is one final enzyme called ligase has to come along. DNA ligase. And DNA ligase is going to attach each of these little sort of fragments together. So let's get yet another color, perhaps a nice purpley mauve color. And let's draw right here and here and here this DNA ligase. So we'll call it DNA ligase. What's a ligature? Is there anybody going to be a doctor soon? Doctors often refer to stitches as ligatures, because what do? They close up, they stick things together, right? A ligature is a way of tying things together specifically. And so ligase is an enzyme that ties things together. So you can remember that based on that. So what it's doing is it's essentially working on the gap. So what I'm going to do is in black, I'm just going to put the gaps here, just so you can still see them, right? But they would just be purple or green. They'd be filling in the gap, forming bonds, and making the DNA completely finished and essentially the same as it was before. Okay? And that's the basic process. So to review the whole process, in summary, helicase opens molecule, unwinds it. Once a section has been unwound, then the RNA primases can move in and begin to assemble the little RNA marker pieces. On the leading strand, only one is needed. And in fact, again, I'd have to double check on this, but I think this one never actually gets turned into DNA, just as a technicality, because it's a marker. It's not read as. I'm not sure if that does or not. I'll have to look that one up for you. But the point is that it produces these marker RNAs, which essentially are telling the DNA polymerase 3 where to begin its assembly of the DNA. So after the primase is gone, in this picture we see the DNA polymerase 3 building the pieces of DNA in their place. On the leading strand, it simply chugs ahead and follows the helicase, making a nice, long, uninterrupted strand of DNA. But on the bottom, because it has to go from the 5 to the 3 end, the 3 to the 5, now here's the thing, right? The confusing part of the 5 and 3 is on which strand are you talking? Are you talking about the strand it's riding on or the strand that it's building? Because the strand it's riding on, if you look at the one on the bottom, it's riding on the green strand, and it's going from 3 to 5. But it's building from 5 to 3, isn't it? So you just have to keep track of that in your mind. They ride from 3 to 5, they build from 5 to 3, right? So the piece, if I right here, this piece that it's making is moving from right to left in the 5 to 3 direction, but it's riding on the green piece down below in the 3 to 5 direction. So just kind of remember that and make sure that you keep that straight in your mind. So these guys are building this. On the bottom now, on a lagging strand, we have this incidence of getting fragments of DNA because obviously when this gets to here, it has to stop because of the other marker. And so therefore we get the Okazaki fragments. And then afterwards we have the DNA polymerase 1, which comes in and replaces the fragments of RNA with DNA, producing a nice even chain on both sides. And then the last step is DNA ligase, which has to come in and actually bond those segments of DNA that were replaced by the DNA polymerase 1, so that they're actually stuck to the ones next to them. And now we have a nice complete picture of DNA, and it's being replicated. Okay? So DNA polymerase 3, its job is to assemble DNA fragments in the open space that's left. See, this here is an open space. There's nothing there. And so what it's doing is it's enabling, so nucleotides would be floating around in the mix, right? They're floating around in the nuclear cytoplasm or cytosol. And so what's happening is, as one floats by, this enzyme has an active site that allows it to attach and grab, and therefore it can attach to the bottom strand. So it's building the DNA strand along this sort of open-ended gap. It's building DNA. The DNA polymerase 1, however, is not doing that. What it's doing is it's changing the RNA pieces into DNA. There's no gap here. There's an RNA piece that has to be eliminated. So its enzyme has the right active sites to break apart the RNA piece, or nucleotide that's bonded there, and also bring in a DNA nucleotide. Get rid of the yellow. That's exactly what they're doing. So now it's, because remember, the yellow is RNA, right? And now when it's done, it's all DNA. It's all copied like this. And then the ligase ties everything together. And that's essentially the way it works. Okay? All right. And that's where we'll stop. DNA replication.